last notes, we looked at the difference between adding and multiplying terms. And what I want to look at now is the difference between multiplying terms and multiplying polynomials. So once again, we're going to have two columns. And we're going to label the first one multiplying terms versus multiplying polynomials. So if I have the terms 3x squared times 2, and that's all squared, that's simply multiplying all of my terms, versus if I have 3x squared plus 2, and that's all squared, we can see right away that there's a difference between those two problems. This one is multiplied, the two terms, and here we're adding two terms. So let's go over here. When we were doing 3x squared times 2 all squared, we were using that mnemonic device MADSPM for properties of exponents. So we're going to want to do that here. So we have a power to a power, which means we're going to multiply our exponents. And once again, let's remember that 3 has an exponent of 1 and 2 has an exponent of 1. So that means that this exponent of 2 gets multiplied to every exponent, which means then that we're left with 3 squared times x to the 4th times 2 squared. Well, we know from PEMDAS that we have to do our exponents first before we can multiply our numbers. I'm just going to write PEMDAS over here. So you have to decide when you're using MADSPM and when you're using PEMDAS according to what's happening with the equation. So for PEMDAS, we have to do our exponents before we can multiply our bases. So we have 3 squared, which is 9, x to the 4th, I can't do anything with that, and 2 squared, which is 4. And again, I'm going to put in a little multiplication sign here. So 9 times 4 is 36, x to the 4th. Before I go on to talking about multiplying polynomials and doing this, what I want to do is I want to show you what students often do that's wrong. So I'm going to take you down to the bottom part of my notes. And I'm going to label this y, taking 3x squared plus 2 all squared does not equal 3 squared x to the 4th plus 2 squared. Notice what I did over here. I distributed that to all my exponents, a power to a power. This is not true. This is wrong. You can't do it this way, and I'm going to show you why. So let's pick some number for x. We're just going to say let x equal 4. So what would that mean? Well, we're just going to substitute 4 in for x. So this would be 3 times 4 squared plus 2 all squared. Once again, we have to remember our rules for PEMDAS, correct? So I'm going to write that over here. We've got to remember these rules. So our order of operation tells us we're going to look inside the parentheses and we have something that's to an exponent. So we have to do that first. So this is going to be 3 times 4 squared, which is 16, plus 2 all squared. Then we have to do 3 times 16, which is 48, plus 2 all squared. And that gives us 50 squared, which is 2,500. So that's our answer. That's what we're looking for. Well, if we did it like this, by distributing in that power, this is what it would look like. Now remember, I said this is wrong, and I'm going to show you why it's wrong. If I can distribute that in, I should get the same answer, and I'm going to show you that's not going to work. So I'm going to substitute in like I did before. So this is 3 squared, 4 to the 4th power, plus 2 squared. Using my rule of PEMDAS again, that would mean I would have 9, 4 to the 4th power, that's 4 times 4 times 4 times 4, which is 256, plus 2 squared, which is 4. 9 times 256 is 2,304. And 2,304 plus 4 gives me 2,308. Clearly not the same. Did not get the same answer. That's why this is wrong. We cannot do that. So keeping that in mind, let's go back up to where we're multiplying polynomials. So what does this mean? Well, what does it mean to have something squared? This is the same as saying 3x squared plus 2 times 3x squared plus 2. It's the only way we can do it. So we're going to set this up using our box. So I have 3x squared and 2, 3x squared and 2, 3x squared times 3x squared. Now, I'm multiplying two terms. When I'm multiplying two terms, I'm going to use my property of exponents because I'm multiplying two terms. So that's going to be 9x to the 4th, because when I multiply the same base, I add my exponents. 3x squared times 2 is 6x squared. 2 times 3x squared is 6x squared. And 2 times 2 is 4. So with the box, we usually have like terms on the diagonal, and we do. So now I'm going to add all of my terms on the inside, which means I have to think about what do I do when I add polynomials. I have to combine like terms. So my answer is 9x to the 4th plus 12x squared plus 4. That is my answer.